We've got the biggest dreams of putting our eyes on other worlds, traveling to them, making them our home. But how do we get there? The stars are so far apart. We would need sailing ships that could sustain human crews over the longest haul of all time. The nearest star is 4 light years away. That's 24 trillion miles to Proxima Centauri. Just to give you some idea of how far away that point of light really is, if NASA's Voyager 1 spacecraft, which moves at a pretty good clip, 38,000 miles an hour, was headed for Proxima Centauri, it would take 70,000 years to get there. And that's only the nearest star out of the hundreds of billions in our galaxy alone. So if we want to endure as a species beyond the projected shelf life of our own planet, we'd better act like the Polynesians. We need to take what we know of nature and build sailing ships that can ride the light as they once rode the wind. These sails are enormous, miles high, but they're very thin. 1,000 times thinner than a garbage bag. When a photon of light strikes those magnificent sails, it gives them a little push. This means that in the vacuum of space, even the tiniest push from a photon will propel them ever faster until they're moving at a significant fraction of the speed of light. When you get too far from your star and the light dwindles, lasers can do the trick. If we were to light sail our way to Proxima Centauri, it wouldn't take 70,000 years, but only 20 years. Proxima b lies in the habitable zone of its star, but we don't yet know if it could support life. Does it have the kind of protective magnetic field that has sheltered the evolution of life on the surface of our world? Another consequence of Proxima b's close location to its star is that the planet is probably tidally locked. One side perpetually facing the star, the other doomed to endless night.